Namaskar. The topic of discussion today is on ocean morphology and relief. You are all aware that seas and oceans are the blue beauties of the planet Earth. Oceans are very vast body of saline water occupying the great depressions of the earth. They belong to the hydrosphere and cover almost 97% of it. Oceans cover 361 million square kilometers of the earth's surface. The volume of water in oceans is 1.37 billion cubic kilometers. Oceans are extensive, exhaustive and exploitable marine ecosystems. Very huge masses of water with varied dimensions exist as oceans. Oceans have both onshore and offshore marine ecosystems. These are characterized by very distinct features with unique fauna and flora. Oceans hold many marine habitat and contain a lot of natural resources. When we move towards the seashore, we may see the beaches with splashing tides and dancing waves. There is a bluish water body standing as a straight flat plane denoting the sea level in front of you. Waves which are coming towards the land are fully broken down near the coast and subsided while touching the beach. The coastline forms the boundary between land and the oceans. The surface beneath the oceanic waters is characterized by a lot of relief features. The structure, configuration and relief features of the oceans also vary from one place to the other. All major oceans and seas vary in their sizes, shape, depth, aerial extension and in all other aspects like temperature, density, salinity and chemical composition. The marine geological, chemical and biological information and data are also very vast and useful for studying and analyzing the oceans. On the basis of bathymetry and other studies, the morphology of ocean basins can be studied. These include the continental margins which are encompassing the continental shelf and the continental slope, the deep ocean basins encompassing the abyssal plains, abyssal hills, oceanic trenches and mid-oceanic ridges. In this episode, the following aspects are going to be seen: mapping of ocean basins, the continental shelf, the continental slope and submarine canyons, the features of deep ocean basins and the mid-oceanic ridges. Let us see the first part, mapping of ocean basins. Oceanic dimensions range from around 1500 kilometers for the minimum width of Atlantic to more than 13,000 kilometers for the north-south extent of the Atlantic and also the width of the Pacific. Typical depths are only 3 to 4 kilometers. So, the horizontal dimensions of ocean basins are 1000 times greater than the vertical dimension. The amount of land above the sea level is very much less than the volume of the sea itself. It is seen from the graph that the average height of land is 840 meters and the average depth of the ocean is about 3795 meters. The world's ocean floor is also uneven. The principle that causes the unevenness of the ocean surface is the gravity. Oceans accumulate a lot of sediments and debris due to gravitative settling. The sedimentation rate of the whole world shows this unevenness also. The actual shape of the earth is not a perfect sphere, it is not even a perfect ellipsoid, but it is an oblate spheroid. If you measure the strength of the gravity field across the earth's surface, you will find local variations caused by irregularities in the crust which produce an irregular surface called the geoid, which is the actual shape of the earth. To find the surface caused by ocean circulation, oceanographers mathematically remove the sea height caused by gravity and create maps of ocean topography. They then calculate the speed and direction of ocean currents similar to that of the meteorologists, using atmospheric pressure maps to calculate the winds. Altimetry is the measurement of the height of the sea surface above or below the reference levels. Ever since people started sailing the oceans, attempts have been made by them to map these oceans. Ptolemy has prepared the oldest map of the earth with the oceans. Modern knowledge of the ocean began with voyages of discovery of Christopher Columbus in the year 1492 and Vasco da Gama after 1497 and Ferdinand Magellan after 1519 and many other people. They laid the foundation for global trade routes stretching from Spain to the Philippines in the early 16th century. The routes were based on good working knowledge of the trade winds, the westerlies and the western boundary currents in the Atlantic and the Pacific. The early European explorers were soon followed by scientific voyages of discovery led by James Cook after 1728, Charles Darwin after 1809, Sir James Clark Ross and Sir John Ross. All of them surveyed the Arctic and Antarctic regions from the Victory, the Isabella and the Erebus. Edward Forbes after 1815 studied the vertical distribution of life in the oceans. Others collected oceanic observations and produced useful charts, including Edmund Halley, who charted the trade winds and monsoons, and Benjamin Franklin, who prepared the chart of the Gulf Stream. Slow ships of the 19th and 20th centuries gave way to satellites, drifters and autonomous instruments for mapping the oceans. The term topography refers to the elevation of a land with reference to the sea level. The term bathymetry refers to the depth of water column below the sea level. Bathymetry also refers to the depth zones of ocean basins depicted as charts and maps prepared using depth sounding techniques. The words bathos means depth, metry means measurement. The measurement of ocean depths in the Mediterranean Sea was started as back as 85 before Christ. In 1872, the HMS Challenger expedition was the first to use fully the methods of bathymetry. The Challenger was the first vessel used to systematically record the information about all the oceans except the Arctic. It also recorded the depths, circulations, temperatures and the organic life. In the year 1925, the Meteor, one of the oldest South Atlantic Ocean expedition, used echo sounders for depth measurements using sound waves. In the year 1950, the sophisticated precision depth recorders were used for measuring the ocean topographic features. Then came the satellite oceanography. Satellite oceanography is a milestone in ocean analysis. The launching of CSAT in the year 1978 was the first oceanographic satellite, revolutionized the measurements of physical properties of the oceans. The launching of CSAT in 1978, the first oceanographic satellite, revolutionized the measurements of physical properties of the oceans. Within a few years, the sea surface temperature, wave height, variations in sea surface contours, ice cover, chlorophyll content and other parameters were measured and reported almost instantly from the satellites. Satellites now observe the oceans, air and land. Thousands of drifters observe the upper 2 kilometers of the oceanic surface. Data from these systems, when fed into numerical models, they allow us to study the earth as an ecosystem. Next comes the ocean bathymetry. Ocean bathymetry was used as the basis to conduct all expeditions and experiments in different depth zones of oceans. The precision depth recorders of 1950s and the multi-beam echo sounders help to efficiently and accurately map the ocean relief features. A hypsographic curve is a graphical representation of the area of Earth's surface above any given elevation or depth. This may be above the sea level or below the sea level. The morphology of the ocean basin means the configuration of the ocean basins in terms of relief features. This could be analyzed by using these bathymetric records. Great ocean bathymetric mapping, marine explorations and expeditions have provided us enormous data and information about the oceans of the world. The world's ocean floor as mapped by Bruce Heezen and Mary Thorpe is presented here. This map shows the spreading zones, subduction zones with their trenches. Let us see the morphology of the oceans one by one. The first one is the continental shelf. Continental shelf is the first morphological unit of the oceans located adjacent to the coastline. It is an extension of the land beneath the ocean surface. The width of the shelf zone ranges from 60 to more than 1500 kilometers. The water depth of this region may go up to 150 meters. At the end of it, the shelf break comes with a marked increase in the slope. In some places, continental shelf is almost not existing. Around Africa, continental shelf is very narrow. There is a very wide continental shelf in the northwest coast of the Europe. The Pacific coast of North America has a narrow continental shelf. The Atlantic has a very wide continental shelf. At present, continental shelf comprises 6% of the Earth's total surface area. 70% of the continental shelves are covered with thick deposits of silt, sand, mud and sediments derived from the land. The UN Convention on the Continental Shelf of 1958 granted the right of mineral exploration up to a depth of 200 meters in owning countries' coastal waters. It also authorizes the use of drilling rigs and other activities within the limits. In 1982, the UN Convention on the Law of the Sea came into effective force. Through this, the continental shelf has a legal limit of up to 200 nautical miles from the coastline. You may be aware that 1 international nautical mile is equal to 1.8520 kilometers. This right also gives exclusive rights to all natural resources within that area. Such shores are known as territorial waters. The continental shelf is built up with sediments washed down to the sea by the rivers of the continents. Continental shelves are the extended perimeter of each continent and associated coastal plains. They are treated as physiographic provinces of the oceans. Continental shelves are considered to be the continental margins. There are two types of continental margins, as active continental margins and passive continental margins. Active continental margins are narrow, relatively steep shelves subjected to frequent earthquakes. Due to these tectonic disturbances, the sediments are moved down towards the slopes and the deep oceans. Passive continental margins are very wide and shallow shelves. They are often made of thick sedimentary deposits derived from the erosional actions of the neighboring continents. The shelf area is subdivided into three divisions as inner continental shelf, mid continental shelf and outer continental shelf. Continental shelves are covered by terrigenous sediments which are derived from the erosion of continental masses. Much of them were deposited during the last ice age. They are called as relict sediments. This has happened when the sea level was 100 to 120 meters lower than the present day sea levels. Marine sediments became increasingly fine with distance from the coast. Sand is limited to the shallow regions. Silt and clays are deposited in quieter and deep waters far offshore. Continental shelf sediments accumulation happens at the rate of 30 centimeters per 1000 years. This rate is faster than the deep sea rate of sedimentation. Continental shelves are very narrow when there are high mountains very close to the coast. They are very wide on the coast, which have a vast and plain land area adjacent to it. Continental shelves will also be very wide in front of the river mouths with exceptions. Continental shelves are very significant morphological units of the oceans because they provide ideal habitats for marine life. Continental shelves are ideal environments for coral reefs to grow. Shelves are also easily subjected to marine erosion and deposition. The origin of continental shelf varies from one place to the other. It may be formed due to marine erosion, subsidence of the coastal belt, faulting and then submergence. The boundary of the continental shelf on the ocean side is determined by an abrupt change in the slope and a rapid increase in the depth. This portion is called as continental shelf break. Next comes the continental slope and submarine canyons. This is the region next to the continental shelf. The width of the zone may go up to 150 kilometers inside the sea. The water depth may range from 200 meters to 2000 meters. This is a zone of steep slope. The slope may range from 5 degrees to more than 60 degrees. In this steep topographic gradient, there may be no marine deposits. Many of the sediments may directly move down into the deep ocean basins. The continental slope zone occupy 8.5% of the total area of the ocean basins. Within Atlantic Ocean, it is about 12.4%. Within the Pacific Ocean, it is about 7%. In the Indian Ocean, it is about 6.5%. Continental slope is geologically not belonging to the oceanic crust, but a part of the continental margin covered by the oceans. Continental slope marks the boundary of the continental granitic mass and defines the boundary between continental crust and oceanic crust. Continental slopes are the longest and highest slopes on the earth. The slope may be straight or curved. The most outstanding features of the continental slopes are the presence of features like submarine canyons. The origin of continental slope is very wide. The origin of continental slope is varied. They are formed due to erosional methods, tectonic methods and aggradational processes. Next comes the submarine canyons. Submarine canyons are steep-sided and V-shaped valleys with tributaries similar to those of river-cut canyons seen on the land. These are formed due to continental rifting. The distributary channels are called as levees. Submarine canyons are located in transverse direction to continental shelves. The fan-shaped deposits of these canyons, which are dumped at the bottom, are known as deep sea fans. These are distinct underwater alluvial fans. They are transported and deposited by turbidity currents. Submarine canyons may have a width ranging from 1 kilometer to 15 kilometers. The relief may range from 20 meters to 200 meters. The water depth may range from 20 meters to 2000 meters. These are almost unique features inside the seas. The lower portion of continental slopes grade into continental rises. They do not have any sharply defined boundaries. A rise is merely a general region where the floor of the deep ocean basin rises to a greater and steeper slope. At the base of continental slope, the topographic gradient decreases to 1 degree or less, and the ocean enters into the abyssal plains or hills. This portion of the sea floor is known as the continental rise. This is a product of deposition by turbidity current, underwater landslides and many other processes. Let us see the features of deep ocean basins. The abyssal plains lying at the depths of 5000 to 6000 meters are nearly flat plains. This is mainly due to sedimentation. They are found mostly in the Atlantic and are absent in the eastern Indian and most of the Pacific Ocean floors. If there are no plains, then there may be oceanic trenches. Oceanic trenches are long, narrow depressions in the ocean floor. They reach a depth of about 7000 to 11,000 meters below the sea level. They occupy 1% of the surface of the earth. The following are the morphological features of the deep ocean basins. The width of the deep sea trenches varies from 30 kilometers to 100 kilometers. The relief of these features may go up to 2 kilometers with a water depth which may range from 5000 to 12,000 meters. The width of abyssal hills may range from 100 meters to 100,000 meters, that is roughly about 100 kilometers. The relief may range from 1 meters to 1000 meters. Most of the trenches lie parallel to the mountain ranges. There are about 26 trenches in the world oceans. 3 of them are in the Atlantic Ocean, 1 is in the Indian Ocean, and 22 of them are in the Pacific Ocean. There is yet another feature within the ocean basins at the interior zones. They are the mid-oceanic ridges. The mid-ocean ridges and rises are formed in the zones of tension where the continental plates diverge. These ridges aerially cross to more than 65,000 kilometers of the deep ocean basins. These are the largest single topographic features seen in the world. The mountains of ocean ridges are not similar to the mountains of the continents. The ocean ridges are composed entirely of basalts and are not deformed by any folding. Ocean ridges are the most remarkable features. These cover nearly 23% of the earth's surface. The ridges are of two types, as active spreading center ridge and rise and inactive aseismic ridge. The active spreading ridges are about 1000 kilometers wide and 1 to 2 kilometer high. There may also be ridge valleys. The ridge valleys form due to the subsidence or downfaulting of the central portions where two plates are diverging. Oceanic ridges are traversed by series of fractures with steep sides running perpendicular to ridges or rises. There are numerous ocean trenches inside the water masses beyond the continental rise. The greatest depths of oceans can be seen only in the form of ocean trenches. These are steep sided, long, narrow and hollow portions. They may be 300 to 500 kilometers in length and 30 to 100 kilometers wide with a depth of 6 kilometers. Initially, their sides slope at 4 to 8 degrees and then goes up to 16 degrees to depths more than 10 kilometers. For those parts of a depression which exceed 6000 meters in depth, the term ocean deep is used. Ocean trenches are formed due to subduction of the oceanic crust. The falls which transect these ridges are called as transform faults. Next comes the island arcs. Island arcs are curved chains of volcanic islands. They are generally convex towards the open sea. Due to this nature, they are called as arcs. There are hundreds and thousands of extinct volcanoes in the ocean floors. These regions are seismically active zones. Island arcs are topographically and structurally continuous features. These are formed when two oceanic plates converge and collide. The melting of the descending plate rises upwards as an extended magma to form these islands. Most of these eruptions are unnoticed. In some localities, especially in islands, one can see the impacts as mud volcanoes and hot springs. Various features found in the ocean basins are not permanent. Some parts of the ocean may be closing due to plate movements and some part may be expanding. This process of opening and closing of the ocean basin is called as Wilson cycle. Sea mounds and guyards are some more unique features of the ocean basins. Sea mounds are isolated steep-sided submarine volcanic mounds. They may be 2 to 100 kilometers wide and less than 1 kilometer high above the sea floor. Very rarely they rise above the sea level, as seen in Hawaii Islands. Guyards are flat-topped mountains. The flat top is created due to wave action. It is named after the Swiss scientist A.H. Guyot. Sea mounds are more than guyards in the world. Nowadays, digital terrain models of sea mounds are generated from multi-beam sonar data. These methods are in a position to provide the three-dimensional pictures of the ocean floors and the ocean morphology. Hundreds of millions of tons of sediments are emptied into the ocean every year by the world streams. Of the total volume of sediments, half of it lies on the shelves, slopes and the rises. They are called as terrigenous sediments. The rest are in the deep oceans. These are clays and oozes. They are called as pelagic sediments. The ocean floors consist of rocks of geologically young age. The oldest rock is of Jurassic in age. The age of the oceans and the morphological features of the sea floor have been extremely important to the development of the theory of plate tectonics, oceanic water distribution and circulation, control of marine life and the global climate. Let us see some more of these topics in the forthcoming modules. Thank you.